Hello everyone, I'm Zikra. So I've been given this digital assignment by my faculty, Professor Dhanabal, for computer organization and architecture. In this GA, we basically have to select a microprocessor or controller, and we have to answer all these 10 questions related to it. So in this video, I'll tell how I made this digital assignment, which will also include the reference of the documents and the online tools used to make this digital assignment. First of all, I would like to tell that I have chosen the microcontroller TMS470MF06607. It is a 32-bit RISC flash microcontroller which was manufactured by Texas Instrument in the year 2017. Then I have used an online tool called drawio. It is a very user-friendly tool used to make block diagrams, flowcharts, architectures, etc. Third thing, these are the references to my DA from where I have taken the help to complete my DA. This includes the datasheet for my microcontroller, and this is a technical manual related to it. So let me start how I made this DA. So this is the first question of my digital assignment, which says I have to draw the block diagram of the microprocessor or the microcontroller selected. So as already I've told, I've selected the microcontroller TMS470MF06607, a 32-bit RISC microcontroller. So for drawing its block diagram, I have used the online tool draw.io and have drawn this structure using that. So I'll tell you how I drew it. So first, when you click on Google and search draw.io, you will get this first link. You have to click on it. Then you have to select whether you want to start a new diagram or you want to open an existing one. So here I'll select create new diagram. Then you have to select which kind of diagram you want to draw. For example, it already has some ready-made pre-installed diagram saved in it. But since we have to draw a new block diagram, we will click on blank diagram. You can also select the type of file which you want to save in your drive. Remember, all these things are going to be saved in your drive. So that you can easily access it whenever you want. So I have selected .draw.io. Then I'll select on blank diagram. Then you have to decide whether you want to use the root folder of your drive or you want to store this in a particular folder. So here I'll select the root folder, click on yes. And then it will continue to load for some time. Yes. And then this screen will open. So here you have to basically draw your structures and all using these shapes and all. So first I'll tell you how I draw my diagram. So like for this you can select a square. In this square you will get an option to thicken the boundary and all using this point where you can see. You can also add color to it using the colors here. So for my microcontroller, I've already drawn this diagram, so I'll open that file for you. This was a microcontroller block diagram which I drew. So as you can see that I have taken the help of different shapes, rectangle, square, and also I've added text to it. So you can still edit it, enlarge it, or resize it. You can also add text to it, and then you can increase the text size using this. Once you are done, you don't have to save it. All these changes will automatically be saved in your drive, so you can access it whenever you want. So the remaining diagrams can also be drawn in the same way, like this internal diagram. It is also drawn using draw.io. This is the editable file for it. You can make use of different kind of shapes or even the dotted lines and the arrows for drawing it. You can add color to it, thicken it, enlarge it, or reduce it as per your choice. Then this PCR diagram has been also drawn using draw.io tool. Then comes the spin diagram. I have taken the spin diagram from the technical manual which is easily available on Google. So as you can see that in this microcontroller it consists of 100 pins with each of the pins labeled properly. Then we have question 2 which says that provide the instruction set of the microprocessing element. So this instruction set can also be found easily using the technical manual if you search on Google. So here I have this instruction set. For this, it consists of approximately 15 instructions. Every microcontroller and microprocessor has different set of instructions. So my chosen microcontroller has approx 15 instruction sets, and these are the flags used by in my microcontroller. So yeah, and these are the clock characteristics, which is also asked in the question. So the TMS 470 device clocks are generated using the global clock module. The device is split into 8 different clock domains, which are mentioned as below, and the characteristics are also mentioned in this table, like CPU clock domain, which is clocked by global clock module, it is generated by any clock source, and all the required comments related to it. Then this comes the device clock domains block diagram. It is also drawn using drawio tool, and I've also provided this editable file if anyone wants to have a look. So in the next question, we have to explain the basic architecture of our microprocessing elements, that is the timers or the interfaces embedded in it. So as you can see that this device contains the following things. It is a 32-bit RISC CPU core. It has a 64 kilobyte total flash with SCCDED ECC, a 512 kilobyte program flash, byte flash, SRAM, interrupt timer, vectored interrupt module. It also has a hardware inbuilt self-test, which is used for checking MBIST and CBU LBIST. It has a 64-bit cyclic redundancy checker, a frequency modulated 0-pin phase lock loop, 2 UARTs, 2 CAN controller, high-end timer, external clock piece scale, and also error signaling module. It also has a 4 dedicated general purpose pins. Then the next question says that we have to talk about the architecture used in this microprocessing element, and then we have to relate it with our computer organization and architecture module which we are studying. So I have talked about two structures, the IAS structure and the von Neumann structure. You can have a look at it by reading it. Then the fifth question says that we have to elaborate register organization of these microprocessing elements. So these are the certain kinds of registers used in my microprocessor element, which includes RTI register, ESM register, PCR register. These are the start address and the ending address. And the next question says that we have to explain the type of algorithms used for unsigned or signed calculations, which includes that of addition, multiplication, subtraction, etc. So for this addition, this is basically the normal DLD additions which we perform. Only thing we have to keep in mind is the overflow rule, which says that on adding two numbers, if they both are positive or both are negative, then only in that case overflow will occur. So as you can see in this last row, when you will add 5 plus 4, it gives you this 1001, and as we know that 1 indicates the presence of 1 in MSB indicates that the number is negative. So in that case, since 5 and 4 are positive and 1 indicates negative, so in that case overflow occurs. Then subtraction is also performed in the same way. Only thing we have to keep in mind is the overflow flag generated. Then this is the flowchart for the subtraction and addition. We have used two registers, register B and register A, and then for every subtraction or addition we have to use a complementer. This SW indicates a switch which will indicate that this particular flowchart is either performing addition or subtraction. Then finally the result after complementer will be added to the adder, and this OF here indicates the overflow bit. Then this is the flowchart for the multiplication. As you can see, this CAM is M implies multiplicand, Q implies multiplier. The count keeps in check of the number of bits still left to multiply. The final result here is stored in A and Q. These are the steps you need to follow while performing a multiplication. Okay, so the next question says that we have to discuss the type of control logic unit used in this microcontroller, and we have to correlate it with our COA module. So I have talked here about two control logic. First is hardware control unit, second is microprogram control unit. So the control hardware is a state machine changing its state with every clock cycle, which means that whenever the clock cycle changes, the hardware control unit also changes its state. Betting on the contents of the condition codes and the instruction register. The outputs are control signals. Here, the outputs are the control signals, which helps you to drive the CPU. The wiring of the logic elements named as hardware determines the sequence of the operation carried. So this is the diagram for a hardware control unit. They are also drawn using drawio. An example of hardware control unit is the RISC architecture, which is our microcontroller, the one which I have chosen. Then I've also talked about the microprogram control unit. In this, the control signals operations are mostly stored in special memory units called control words. The control signals admire machine language programs, like they understand machine language programs. So whatever instruction you are giving to the microcontroller, make sure that it is in machine language. It is slower in speed than the hardware control unit. And these are some of the important terms which one needs to keep in mind while talking about the microprogram control unit. And this is again the diagram for this control unit. The next question about which we have to talk is the memory management and the addressing modes used in this microcontroller. So as you can see, these are the registers and the memory modes which are used in this microcontroller. Yeah, these are the addressing modes: constant addressing mode, post increment addressing mode, and various other kinds of addressing modes which are mentioned in the technical manual. Then we have to elaborate the pipeline and parallel processing capabilities and the unit and hazard management techniques. So first of all, one needs to understand what is a pipelining. So the process of accumulating instructions from various processors through a pipeline is termed as pipelining. It allows the accumulating and execution of instructions in an ordered process. This term is called as pipelining processing. It may be a technique where multiple instructions are overlapped while execution, like you can see. There are multiple instructions S1, S2, S3 which all are overlapped together, and then we get the final output. So there are two types of pipelining: arithmetic pipelining and instruction pipelining. And then here we talked about the parallel processing capabilities. Parallelism is a multiple operations happening at the same time. It generally occurs at the same time. It exploits a potential parallelism among instructions. This parallelism is named as instruction level parallelism. In the same way, you will also study about the arithmetic pipelining. Then we have hazard management techniques, which includes the structural hazards, data hazards, control hazards, etc. Structural hazards generally arises from conflicts of resources when hardware cannot support all possible combinations. Then we have data hazards, which arises when an instruction depends on the result of the previous instruction. Control hazard arises from the pipelining of instructions and branches. When we are using multiple branches, then this control hazard arises. Then we have also talked about what's a cache miss and a hazard in pipeline. Then the last question is we have to find whether the parallel level parallelism is supported in our microcontroller or not. So I've got this answer that it doesn't support processor level parallelism. So you can get this answer by looking at or reading at the technical and the datasheet of this microcontroller. Then we have talked about cache coherence protocol, which includes the MOSI protocol, MESI protocol, and the MOISI protocol. Then we also talked about cache hit. A cache hit describes matters where a site's content is successfully served from the cache. The tags are searched within the memory rapidly, and when the information is found and skimmed, it is considered as cache hit. For example, if you're searching for instruction and at an address, and if you found that instruction at the same address, then it's called cache hit. Similar way, cache miss is when you don't find the particular instruction at the address specified. Then there are three types of cache: hot cache, cold cache, and warm cache. And cache miss is already described. If you don't find a particular instruction at a specified address, it's called cache miss. So as discussed, you can find all these informations in this technical reference manual, which you can easily get if you search on Google. It contains all the necessary information about your microprocessor, and also you can make use of this data sheet, which also will help you to complete this DA. It also tells you clearly about the features and the block diagrams, functional block diagram, the registers used, and everything, even your device configuration. So these two things are easily available on your Google, and I've also attached a link in my PPT. You can search that link and you will find these two documents easily. So that's all from my side. Thank you for watching this video.